we're going to look at trigonometric identities in lesson 91. Now that sounds complicated, but it's nothing fancy. All right, it gives you sines and cosines and tangents, which looks fancy, but it's really just basic overall math. So trigonometric identities. All right, fun to say. There's two different trigonometric identities we're going to look at in lesson 91. Forgot to upgrade. Lesson 91. The first one is tangent of theta equals sine of theta divided by cosine of theta. Now, if you want the proof for all of these, that's kind of more in the book. I'm going to focus on the math behind it. But if you want the proof and the why this is an identity, you're welcome to investigate that in this lesson. And then the second trigonometric identity is sine squared of x plus cosine squared of x equals 1. Now, if this looks familiar, this is ultimately kind of where Pythagorean theorem comes from. And it's kind of the proof behind it. But once again, the proof of that, not going to investigate that in this video, but you're welcome to look at the lesson. So now let's look at a couple of examples of how we might use these in math problems. In example 1, it says find sine of theta if cosine of theta is 0.5. Well, my first thing I'm going to do is I'm going to look at, okay, which one of these two trigonometric identities uses sine and cosine? Well, obviously this one does, but that's for if it's equal to tangent of theta. We're not going to need to do that. We're going to go ahead and plug in to where we're going to have no more variables. So when I plug in, okay, sine squared, I'm going to call it theta, sine squared of theta plus cosine squared theta equals 1. Well, I know what cosine of theta is. I know that that is 0.5. So I can plug in 0.5, and it does stay squared. That does stay there because I'm only plugging in for. I don't know what cosine squared theta is. I only know what cosine theta is. If it was like that, I could plug in the whole thing, but it's not. So now I'm at a point where I only have one variable in sine of theta. So now I'm allowed to solve. So 0.5 squared would be 0.25. Got to get sine of theta by itself because that's what we're trying to find. That's our goal here. So I subtract 0.25. I'm going to move this over here. I get sine squared theta equals 0.75. And then from there, to get the theta, sine of theta by itself, I need to square root to get rid of the squared. So I square root both sides. And when I square root 0.75, I end up getting 0.87 roughly. And that would end up being sine of theta. So that's all you're doing on the math side of it when you're plugging in. So now let's look at one more. Example 2. It says express tangent of theta using only sine. So it wants us to show tangent of theta, but it wants to use only sine. So that means it wants to get rid of the cosine. We're going to have to figure out how to plug in a variation of sine in for cosine. So I'm going to write this formula over here and isolate it. And what I need to do is get cosine in terms of sine. So how do I do that? Well, let's look back at trigonometric ratio number 2. Let's look here. Is there any way I could get sine of theta equaling everything else? And right now, everything equals 1. Is there any way I'm able to understand and know what sine of theta is? Well, if I subtract cosine squared, I'm going to change these to thetas. If I subtract cosine squared theta, what I'm going to get is sine squared theta equals 1 minus cosine squared theta. And to get sine theta by itself, because that's what we only want sine of theta, I'm going to square root here, square root here. So that leaves me with sine of theta equals square root of 1 minus cosine squared theta. So now that I know what sine of theta is, oh gosh, did I just solve for the wrong one? Make sure I didn't solve for the wrong one. I did it backwards, my bad. I needed it to be using only sine theta. Sorry, let me make sure I got this right. Yeah, since I only want in terms of sine theta, I want to be able to plug in for cosine. So let me go back one step. It's all actually going to end up being the same thing. I just need to subtract the sine squared of theta. That was my bad. So cosine squared theta equals 1 minus sine squared theta. Square root both sides, okay. So now we're here, same thing. So now I can plug for cosine of theta, I can plug in for right there. So now I get tangent of theta equals sine of theta divided by square root of 1 minus sine squared theta. And now there's no cosine within that expression. So tangent of theta is expressed using only sine, no cosine. Got rid of it. And if you want to just see how to plug these in, like I kind of saw for that one, if you just look at page 596 in the top box, it has all the different expressions to prove the trigonometric ratios. But that's kind of how you might have you do the math, but that's all there is to lesson 91.